Welcome back to Data Within Reach, and welcome to another Rapid R 3-minute tutorial. In our last tutorial, we talked about regression trees, and in this tutorial, we're going to go over random forests. Random forests are a collection of regression trees where each regression tree's features are selected at random. I'm really looking forward to today's tutorial, so let's get started. The category for these types of predictors are called ensemble learners. That is to say, learners where they take a bunch of different estimates and then average it out. An individual random regression tree would be quicker to create than one where you actually find the correct feature for the branch. Instead of having to run a correlation analysis to find the best feature, you just pick one at random. That's going to be quicker. Problem is, when we create a forest, we're going to do it like 100 times and then take the average. So at the end of the day, it's going to take longer to build up a random forest than it is going to take to build one carefully created regression tree. Random forests are much less likely to overfit, and as we'll see in our tutorial today, they produce a better mean squared error result, as long as you use sufficient trees. Just like always, you start your project by loading up the libraries you need. To create a random forest, you're going to want to load the R library random forest. Pretty well named library. If you haven't installed it already, run the install command, and no matter what, you have to run the library command to have it at the ready for R to use. Similar to our last tutorial, we'll go with the housing price data in the Massachusetts area, and we'll pull out the Boston data set. Just so that we keep getting the same answer over and over again, we're going to set a random seed. In this case, we're setting the seed to 42. The Hitchhiker's Guide to the Galaxy constant, as I like to call it. For this tutorial, we'll split the data into 80% and 20%. Train and test. That way, we're really figuring out how predictive our models are by separating out the training data from the test data. Now, the command to create a random forest, once you have that library loaded, is really straightforward. It's random forest. The parameters that you're going to need to put in are the median value variable. That's the column median value from the Boston data set, which is the next parameter, data equals Boston. The last parameter that we're entering in this example is the number of trees equals 100. This is the number of random trees we want to generate. What we're doing is we're trying to find a nice happy medium. This is what we call in data science a hyperparameter. If we set number of trees equal to 2, wouldn't give as accurate of an answer as our regression tree. If we set number of trees equal to 50,000, it might take a long time to build up and to use. In this case, number of trees equals 100 is a nice middle ground. The next section of code is something that I pulled from the previous tutorial. So here we're just creating one tree, and it's a tree where each feature is carefully predicted to be the correct and most likely feature that will differentiate. So we're comparing one tree that was very carefully created to 100 trees that were generated with random feature selection. So now let's use that test data to calculate our mean squared error. We'll take our one regression tree, figure out what the mean squared error is for it, and then we'll take our random forest and figure out what the mean squared error is for it. This command here prints out the results, and what do you know? Mean squared error is lower for a random forest than it is for a single tree. Excellent. Well, I hope you enjoyed this Rapid R 3-minute tutorial, and if you did, please give it a like and subscribe. And if you didn't, well, here's a joke for you. Why did the tree quit its job at the forest? Nobody knows. Leadership is stumped. Anyways, have a great one. We'll see you soon. Bye-bye.